My name's Rodney Brooks. I'm director of the MIT Artificial Intelligence Lab, and what I like to do is build stuff and build robots, because I'm really interested in what it is that makes us us, what it is that makes something living, and what is that boundary between non-living and living. There's all sorts of hypotheses about what could be the difference between living and non-living matter, and some people refuse to think that it's just material that makes living stuff. There's some life force. I don't believe that. I take the view that anything that's living is just a machine, that I'm a machine, my children are machines, but I don't treat my children as though they're machines. I love them unconditionally. So I interact with them on a different level, but I can step back and see them as being, a bag of skin full of biomolecules that are interacting according to some laws. As far back as I can remember, I was always a weird kid. When I was 3 or 4, I could do arithmetic in my head much better than adults. By the time I was 8, I was starting to build electrical circuits with stuff that I could get my hands on, which was tin cans and nails and scraps of wire. My mother thought it was unhealthy, and she wanted me to come in and watch TV like a normal kid instead of being down in this shed in the back, building stuff. And she'd call me in, an hour before dinner to watch TV instead of thinking and working, and it really frustrated me. As a preteen, my greatest invention was a machine that could play tic-tac-toe and couldn't be beaten. Did it all on paper, did it by hand, and then hand compiled it into a circuit made out of just switches and wires and light bulbs in a way that now, if I tried to do it, would probably take me weeks. I probably did it in 3 or 4 days at a time of intense work, and I just was dogged at it. Almost as long as I can remember, I've been doing this stuff, trying to build things that are intelligent. I can't explain why that fascinated me. It's just been part of me for almost 40 years now. Back in the 80s, I was building robots inspired by insects, 6-legged robots, and my plan had been, okay, I'll get insect robots working, then I'll work on a very primitive reptile, then a primitive mammal, and maybe a cat, and then I'll do a monkey, and then I'll do a human. But after I'd spent 10 years on the insects, I started to add that up, and I figured, damn it, I'm going to go out having built the best cat robot around. That's not what I want my legacy to be. So then I jumped straight to humanoids. I just had to skip everything and just go for it because there wasn't enough time in my life. When we build our robots today, they can do lots of things which are lifelike, and people off the street will interact with them as though they're living and get quite drawn into that. But if we step back, we're not really confused that they're really living systems. They're not as robust, they're not as adaptable. There's all sorts of properties they don't have of real living systems. So how do we get those properties of living systems? And is it just a laundry list? If we have properties A, B, C through H, will that make it living, or is there something deeper? Modern molecular biology is based on the premise that there's just biomolecules. It's chemistry and physics, and there is nothing else. And I believe that. But if so, then we've got this dilemma. How do we go from just atoms and carbon, oxygen, hydrogen, nitrogen molecules, things formed out of those pieces, into something that's living? What is that transcendence between this inanimate stuff and the animate stuff? My hypothesis is that when we look at living systems and try and analyze them that way, we're maybe still missing something. We're missing some key aspect of them. We just don't have it in our scientific vocabulary even now. Some people would say that we're missing some physical property, some chemical property, and that there's new physics and new chemistry needed. My hope is that that's not needed. I may be wrong, though. And that's how little we know. We don't even know whether we need new physics and new chemistry, or the current physics and chemistry is enough, and it's a different abstraction sort of layer, a different sort of thing. We don't even know that. What is it that makes us real and these machines not real? What would it take to build a living machine? And can we ever build something which we would classify as living? More generally, I want to understand, what is life? I want to build living machines. Computer.
I'm already listening.
Open the drapes. Open the drapes. Thank you. Most of what we do fails. You try to get a program running, a big program, you spend months and months on it, and mostly it doesn't work, and mostly it doesn't work the way you thought it was going to work. When you got all these subsystems together, it's disappointment, trying. Einstein, I think, said it's 1% inspiration, 99% perspiration. I think he really underestimated the amount of perspiration. It's just going at it doggedly. And there's no visible reward during that time, so you have to be a really sort of weird person, I think, to be able to force yourself to do that for that one reward that comes so rarely.
Silly then.
But even so, I'd say every 10 years I get one of the biggest rushes that is imaginable, and I can think of a couple of them that I've had. One was when my first mobile robot moved.
Rolo, answer the door.
Sign here.
Another one was when I was building artificial life systems, trying to have systems evolve. And I was in my apartment working late at night. I had a Macintosh computer there. This is the 1992. And finally got it debugged enough. When I hit the return button, this thing started evolving. And before my eyes, new creatures were evolving on the screen and interacting and doing stuff that I hadn't predicted. And I was just laughing, and it was great. It worked. This stuff worked. I'd created life. In between, there's lots of little rewards. The little rewards are seeing Kismet interact with people.
Kismet, look at me.
Hello.
Hello. Yes. This is red too, This is a red horsey. It's very red. Say horse.
Red horsey.
Red horsey, yes.
In artificial intelligence, researchers made a mistake early in the game. They thought intelligence was the stuff that they found hard to do. So the early days of artificial intelligence were all about playing chess and proving theorems. One of the big failures so far of artificial intelligence and robotics is we can't do general object recognition at all. Like a 3-year-old who can see things in the world and say, that's a car, that's a bicycle. That wasn't intelligent, that was easy. But we still can't get our computers to do that, because that's really, really hard and takes up a big chunk of our brains.
Kismet, look at me. Kismet. Oh, yes, that's me. Yes. Yes. If you talk to Kismet, it doesn't really understand what you're saying, but it can pick up intonation, so it understands when you scold it in a very heavy voice. It says, Kismet, no. It understands that that's something bad. On the other hand, if you say things like, oh, Kismet, that's very good, from that intonation, it distinguishes between adults' intention, which is exactly what infants do. So you can see this as a first baby step towards that goal of having something that learns from other humans. What we're trying to do here is build a robot that is more, that can learn in a more open-ended way, in a general manner, meaning ultimately the robot will be able to live in the world and survive the way humans do.
In trying to figure out how to build our humanoid robots, we looked at two sources to try and figure out the modules. One source was how children develop. Different modules in their brain are being activated at different times, and evolution has programmed them to be activated in certain orders so that the earlier ones can adapt and learn what they need to learn without the interference of trying to be involved in this more complex process until later. We also looked at animals, different animals, and see what different capabilities they have. So these two different sources, evolution and individual development, point to the same sorts of modules. Then after we built our first robot and started interacting with it, we saw people interacting with the robot and the robot engaging in behaviors that we hadn't yet programmed into it. So that's what we set out to try and do in our second phase with the robots. Figure out how to have social interaction between a teacher and the robot so that the teacher would naturally lead the robot through and teach it stuff like mothers teach their children without them realizing it. So some of the things that we have enabled our robots to do is to have it so the human can understand where they're looking. We also then have the robot figure out where the person is looking, and then tries to look where the person is looking, because that is the basis for shared attention. That is the basis for then language acquisition. If you're not paying attention to the same thing and the mother's saying something, the mother's saying something about over here and the baby's looking over here, the baby isn't going to learn the language involved with what's going on over here. You have to have shared attention. So there's a mixture of genetics and development. We, the programmers for the robot, are providing what genetics provides to humans.
The inside we have the on-off switch, some batteries, and a 32-bit microprocessor inside.
I'm always an optimist, and I think that with robots right now, we're in the year 1978 for computers. We're seeing the same with robots now. We've had robots in factories for a long time. You can buy the first few home robots. There's hobby clubs, there's how to do it newsletters, there's books, there's kits. I think it's got a chance to take off and be much bigger than computers were, because it lets computation attach to the real physical world and do real physical stuff. Over the last few hundred years especially, mankind has been hit over the head again and again by science. We've had to retreat from our specialness. It used to be that God had placed us at the center of His universe and we were the chosen beings. But over time, we came to understand, no, the Earth is not the center of the universe. And then it got even worse, actually. The sun is just one sun in the Milky Way, and all the Milky Way is just one galaxy out of billions of galaxies. So we're really at a very non-special location in the universe. In the 19th century, again, after culmination of many, many ideas, culminating in Darwin, we found that we were not separate from the dominion of animals. We were the same as animals, the same stuff. Even Darwinism, when you go to the intellectual badlands of America, you still find people saying, that can't be right. even our genes are not that different from yeast genes. We have the same regulatory processes and genes in us as yeast. Recently, Human Genome Project, we had to give up some more specialists. People got really upset. What do you mean only 35,000 genes? We're better than that. Potatoes have a lot more than that. So what's left for us? What's left for us is we're better than machines. They're cold, hard calculating. When Gary Kasparov got beaten by Deep Blue, he said something to the effect, well, at least it didn't enjoy beating me. What's left is we have emotions. So to say that something that's not human, not animal, has emotions is very scary because it's our last bastion of specialness. To say that we're machines, we're not different from mere machines. When people look at these human robots, they say, well, it appears to have emotions, it mimics emotions, but a machine can never have real emotions. Only us or animals can have real emotions.
Here, come over here and take a look at this model of the brain. This is the front of it. Emotions are centered in the lower part of the brain, the thalamus. People have resisted the notion that these robots have real emotions, and at some level, I'm sort of along with them. Do they really have emotions, or are they just simulating emotions?
Kismet, be nice. Say nice.
Nice.
Nice, yes. Be nice. It's good to be nice.
Nice.
Yes.
When will they have really have emotions? What would it take for them to really have emotions? And that gets this question then, is there something we're missing, or do they already have emotions and we're just not willing to use that language yet? When I talk about and show these robots, there are two questions that always come up. Question number one is, will we accept them? And this is the specialness question. Will we treat them the same as us, or are they different fundamentally to us? Question number two is, will they take over from us? And my answer is no, the machines will not take over from us, because there isn't going to be any us for them to take over from. Because at the same time as we're pushing on the silicon and steel machines, we're changing us into robots. We're bringing technology into our bodies, and we're doing it in two ways. First, bringing silicon and steel into our bodies. There are tens of thousands of people walking around with cochlear implants where they have direct neural connections into their cochlea so they can hear. These are people who went deaf, now they can hear again. People are working hard on retinal implants for people with macular degeneration so that they can restore their sight. Putting chips either directly in the eye is one approach, or putting a connection into the V1 area at the back of the head and projecting images into the early visual processing. Lots of clinical pushes for bringing technology into our body. At the same time, we're starting to get exquisite control over what's happening inside living cells. So 50 years from now, our industrial infrastructure, maybe sooner than 50 years, our industrial infrastructure is going to be based on biological material. It's going to be based on the same stuff as us. What we build robots out of will be biomaterials. What we will be biomaterials. We will be the same stuff, and we will change ourselves as a species. Generally, I want to understand what makes us us. How do we work? part of the motivation is also just to see whether we can build a robot that's as good as a human. Now, I don't expect that to happen in my lifetime, but I think we've gotten a lot further than people had gotten before, and this is interesting, and this is fun. Over the last 20 years, I've built hundreds of robots that look like insects, robots that look like R2-D2 and, you know, an upturned trash can that navigate around, and then robots that look like humans. For me now, the fundamental question is, if we are machines, which I sincerely believe we are machines, biochemical machines, how is it that our lifeness arises out of that mechanism? And I believe it does, but I don't think yet we understand it well, because otherwise we'd be building living machines, and we're certainly not building living machines yet. Now, having worked with humanoids for quite a while, there's still a lot to be done, but now I've gotten back to this deeper question of what does it mean to be alive? And I'd like to get a better answer for that. I think if I can do that over the next 30 or 40 years, I'll be happy.